This is another example with regards to how we go about determining the equation for our regression line, also called our least squares regression line. And we want to remember first and foremost that a linear equation will be an equation in the form y hat equals mx plus b, where m is the slope and b is the y-intercept. The y hat means predicted y. So it's not the actual y necessarily, but it is the predicted y. So we know we have to find the slope first. And over here in the bottom right-hand corner, I have identified the formula we've been given for finding the slope. So we can see we're going to need the sum of the product of x's and y's. So I'm going to start there. What I'm going to do is I've set up a set of data here. Now this particular set of data is I've intentionally made perfectly linear, okay? So we should get some nice numbers. So the first thing I'm going to need to do is I'm going to need to determine the product of my x's and y's. So what do I get when I multiply x and y together? And I'll try to color code this to make it a little easier to follow. So my first x and y are 2 and 5. If I multiply them, I get 10. 3 times 7, 21. 4 times 9, 36. And 5 times 11, 55. I'm going to need that sum. And so when I add those up, I get 122. Now I see the next part of my numerator of this formula for the slope asks me to find the sum of my x's. So I'm going to need to add up my x coordinates, 2, 3, 4, and 5, and they add up to 14. The next part of my formula says that I need the sum of my y's. So my y's are here in the second column. 5 plus 7 is 12, plus 9 is 21, plus 11 is 32. In my denominator of this formula, I see, in addition to n, the number of ordered pairs that I have, I see I need the sum of my x squareds. So I'm going to need to square my x's and then add those up. So my first x is 2, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So I get the sum of my x squareds equal to 54. And then I see that the last sum that I am in need of is the sum of my x quantity squared. So all that basically means is take the sum of my x's, which I previously found to be 14, and square that number. So 14 squared is equal to 196. All right, so now I'm ready to compute my slope, okay? Looking again at my slope formula, it says first in the numerator, take n, the number of ordered pairs. I have 4 ordered pairs. Multiply n by the sum of the product of my xy's. That's my blue, 122. Subtract from that the sum of my x's. That's my red, 14. Multiply that red by the sum of my y's in green, and that's my 32. So there's my numerator. In my denominator, once again, I start with n, the number of ordered pairs. I have 4. Multiply that by the sum of my x squareds, which I did in purple, and that was 54. Subtract the sum of my x quantity squared. So subtract from that my gold number, and that was my 14 squared, or 196. So if I compute my numerator portion, 4 times 122 minus 14 times 32, so my numerator portion comes out equal to 40. My denominator, 4 times 54 minus 196, comes out equal to 20. And when I divide the numerator 40 by the denominator 20, I get 2. The slope is 2 in this case. So now I have the slope of my line. What I need next is my y-intercept, and I've written the y-intercept formula here on the screen. I need to take y bar, the mean of my y's. Well, my y's added up to 32. To find mean, that means average. I divide by the number of y's that I have. So basically I'll have 32 divided by 4 minus my slope, which I just got to be 2, times my x bar. Well, the sum of my x's was 14. Mean is average, so I need to divide by the number of x's I have. There were 4 of them. And so my x bar will be equal to 14 over 4. When I calculate 32 divided by 4, or 8, minus 2 times 14 divided by 4, I get a y-intercept of 1. So now I have the important pieces of my regression equation, and I just plug them in. Y hat equals m, my slope, 2, times x, plus b, my y-intercept. There is the equation of my regression line.